Okay, so these notes and videos work through exercise 7B. Starting with question number 1, what we're trying to do is prove one of our integral trig rules. Okay, obviously this one. And the idea is that we're going to find the derivative of this. And by finding that derivative, it means we can find the integral. So think back to your basic integration here. Okay, if I've got y equals x squared, the derivative of x squared we know is 2x. Therefore, we're going backwards, the integral of 2x equals the x squared plus c. So what we're hoping for is that I can show that the derivative of this equals this. And therefore, the integral of that will be arc cos. So that's our plan. Let's see what we can do about that plan. The first thing we're going to do is we want to get rid of arc cos, right? And we go, well, how do we do that? Well, remember, arc cos is really, if we had something like, that's the same as if I had cos to the minus 1 of x over a, but we don't like writing it like this anymore because we don't want people to think that, so cos to the minus 1 of x does not equal 1 over cos x. So that's why we start writing it as arc cos instead. So to get rid of that, we basically cos both sides. So that becomes cos y equals x on a. All right, so that's what we're going to do over here. So we're going to cos both sides, and we're going to end up with cos y equals x over a. I'm going to get x by itself, so therefore x equals a cos y. All going along quite well. And again, if we look over here, this is what we're saying. We're differentiating y with respect to x. So we're going to do the same thing here, right, over here, but instead we're going to reverse a little bit. We're going to differentiate x with respect to y. So that's going to be, derivative of x is 1 dx by dy equals, all right, what's the derivative of cos? It's minus sign, so minus a sine y. Still not really looking like what we want, but here comes the little catch, the little trick. So we want to try and find a relationship between cosine and sine. And the best one that we have is that we know that sine squared theta plus cos squared theta equals 1. So rearranging that, we can rearrange that to say that sine theta must be the square root of 1 minus cos squared. I know you're going, yeah. So what? Well, if we go back over here, we've got cos y. So therefore, if I have, go back to my thing here, if I've got sine y, I can actually now replace that with the square root of 1 minus cos squared y, and therefore we've got dx by dy equals minus a times, now notice this bit here, we've got cos, well, I wanted to change the colour, we'll go yellow, we've got cos squared y, and then we've got cos y over here, so equals x over y. So hopefully you can see that I am allowed to replace that with 1 minus x over a squared, okay, because cos y is x over a, so cos squared y is x over a squared. Now this is starting to look a little bit more like this, one hopes. The other thing we're going to do is, remember, we don't want dx by dy, we want dy by dx. So here's another great thing that we're allowed to do. We can actually flip it. So that becomes minus a all over 1 minus, now when I square a fraction, that becomes x squared over a squared. And it's just one little step or two little steps to finish off. Right, how do we make that look like the thing we wanted at the top? Let's see, we can keep our minus a there. We could how about we pull out a common factor of a squared? So that would have to be not a squared. We'll pull out a common factor of 1 over a squared. So if I pull out 1 over a squared, 1 over a squared times a squared gives me the 1, and minus x squared. Things are starting to look good. Okay. And we are now a step away because minus a, I can square root 1 over a squared. That becomes 1 over a. Okay, we've got that. And that, I believe, leaves us with minus 1 all over root a squared minus x squared. So therefore, the integral of this, right, has to be our original function. So all good. Now let's have a look at applying these rules to simple things. So those were proofs. We don't need to do a whole lot of those. All right, so this one, it's all about match, match, match. Matchy, matchy. So we've got 25 take x squared. We're looking at these rules to the left and we can very clearly see this one here. So if I wanted to rewrite that, that is going to be 1 over 5 squared take x squared by dx. So it's a simple matter of now this is just arc sine x over 5 plus c. So just try and match up with the rules. We look at our next one, 7 over, looks pretty similar, except it's got this 7 here. So you are allowed to actually pull that out. So it becomes 7 over 1 plus x squared by dx. Okay, and then what rule are we going to look at? Clearly it's this one. So that now becomes arctan. Oops, didn't leave room for the 7, did I? It becomes 7 times arctan. What is it? Just x. Okay, x plus. So hopefully this is making a little bit of the sense to you. Let's do the next one. Okay, we've got something. So first it's a square root. Okay, something minus x squared. So it's not a 1. I think again we can go over here. Okay, but this time when we're looking, we're going to say this is the same then as, oops, that's a odd looking one. What's a quarter? So that would be a half squared minus x squared. Okay, so that then becomes arc sine. That will be x divided by a half, so otherwise known as 2x. And last but not least, okay, we're looking at this, we've got the 1, we've got something plus x squared. Again, no square roots. So for this one, oh, let's go orange. Okay, so that one, I think we're looking at this. The problem is, okay, like we just used in the first one, we know that downstairs we can say that to get 1/16, that's a quarter squared. But obviously we need to have the quarter upstairs, but we have a 1. So that's okay. I'm going to put the quarter there. And obviously if I now times by 4, what's 4 times a quarter? That is 1. So this expression, they equal each other. And now I can use this rule with the last one. So that becomes 4 arctan. Okay, x divided by a, my a is a quarter, so that's going to be 4x plus c. So go and have a play, practice all of these, and you're just sort of trying to mush. You might have to pull out common factors, you might have to times things by certain bits, but enjoy it. Right, on to 5. So again, we're looking what rules could we use here for number 5. 1 minus 4x squared. Now the problem is this 4. Okay, and it doesn't sort of fit our rules there because none of them have the 4 out the front. So that's okay. Let's pull this out as a common factor. Okay, so if I go 1 over, I'm going to pull out the 4 as a common factor, and so I get something minus, x squared. So that's good. It's no longer something in front of, but what's going to be here? So if I put that as a quarter, 4 times a quarter gives me the 1, so that works okay too. However, now I've got this 4 here, but remember the whole root a times b, I can separate to root a times root b, so this now becomes the integral of 1 over, separate that, so root 4 is out the front, which is 2, and a quarter is a half squared minus x squared. Guess what? Forgot my little dx's again. Bad, bad, bad. So this now becomes, I can pull out that 1/2. And what rule am I using? The square root, I believe it would be that one. So it's a half integral 1 over root a half squared minus x squared. So this is now going to be a half arc sine. Your a value is once again a half, so x divided by a half is 2x. Huzzah! So you can do, I think, finish off 5, do question 6, stop the video. I am just going to give you a tip with 8 because that is a little bit sneaky and it's making you recall, or hoping that you recall, some of your fraction work. So my hint here, let's use real numbers first. So my hint would be if I had, let's say, 17 over 15, this separates. I can separate this to be 15 over 15 plus 2 over 15. And if I do that, that means 15 plus 15, it's 1 plus 2 over 15. So you're basically dividing, and that's what we can do here. So I can separate this because at the moment I cannot integrate because it's a function divided by a function. We haven't got the skills for that at the moment. So I can separate the top line, I hope you agree, to be x squared plus 4 plus 6 all over x squared plus 4. I haven't forgotten my dx. Oops, it's a big one. And what that now allows me to do is, that means this is x plus 4, because I can put little brackets around that, right? All over x squared plus 4 plus 6 over x squared plus 4, all by dx. So now I'm looking at the integral of 1 by dx plus, okay, we're looking at this rule, so we're going back up, x squared plus 4. X squared plus 4. Again, it looks like it's going to have to be that one. Okay, so I'm going to want that to be, what do I want it to be? I want it to be all over x squared plus 2 squared. So that means I have to have a 2 up the front. What do I have to do to make it 6? So then put the 3 there. And now we integrate as per normal. The integral of x, the integral of 1 is just x. And this now becomes 3 arctan, what was it? X over 2. Done. Don't forget plus c. The exercise uses definite integrals, which I think you should know from your methods work. Just does the same thing, but reminder, go back, look at some of your calculator work, okay, with, you know, what's sine of pi on whatever. You can do that. Arc sine of root 3 on 2. We know those exact values. Your calculator will tell you. So give that a crack. Good luck.